Okay, so what we're looking at here is stuff out of section 5.2 involving binomial PDFs, point density functions, and binomial CDFs, cumulative density functions. So for the purpose of this example, we're going to let n, the sample size, equal 10, p, the probability of success, equal 0.8 or 0.80, and we'll let x, the number of successes, equal 4. Now, in your text on the binomial tables, for example, in the back of the book, they use x for the number of successes. Some texts use r, a lowercase r, just so you know, all right? So first of all, let's take a look at a point density function, a binomial PDF. So if you will bear with me here. Now, this is not drawn to scale per se, but it'll help if you can visualize what's going on. Sort of a sloppy drawing, but it'll give you the idea, okay? First of all, for a PDF, that's like we're finding the probability that x exactly equals some number. In this case, we're going to say 4. Now, what that is that's the area of this bar, which essentially, assuming they're all 1 unit wide, that means it's the height of the bar, okay? So the probability that x equals 4, you can actually find, let me stop share or actually do a new share. Here's my binomial distribution table, okay? Let me get rid of this stuff right here. So this is in the appendix on the back of the book, and this is from an earlier edition of your textbook. So it should be pretty close to this. So if you take a look, n, your number of trials is over here on the left. Right next to that is x, right? And that's your number of successes. So what we want to do is go down to where n equals 10. And that's actually on the next page. All right. So here's n equals 10. For our value of x, we're looking at x equals 4, right? So what we're interested in is this section right here, where your probability of success p going across the top is where you get that, equals 0.8. Now this rounds out, you'll notice, to the thousandth place for these probabilities. Your graphing calculator is going to give you a much more exact value for this, okay? So when we're finding the probability that x equals 4, we're just concerned with this part right here. That is where x equals 4. And so on our table, we look where the probability of 0.80 intersects x equals 4, and that's here at 0.006. That's according to the table, right? That's a point density function. Individual probabilities for individual values of x, okay? As soon as you start working with inequalities, like the probability that x is greater than or equal to, or less than or equal to, or less than or greater than, you're working with the binomial CDF. That's a cumulative density function. Cumulative density functions start at a particular value of x and go to the left. So for example, if we were finding the probability that x was less than or equal to 4, that would be all of these added together, okay? Let me change back. I forgot to stop and go to a new share here. All right, so what you see graphically, and I've colored in the probability x less than or equal to 4 is going to be all of these added together, okay? And so if we go back to that binomial table, that probability that x is less than or equal to 4, again, we'll go to where n is 10, x is 4, and what you're doing is you're adding all of these together. Now, the way they've rounded that off, that's 0.007. Okay? So all of those blue shaded ones added together is 0.007. I'm going to mess some of this up and have to redraw it, but that's okay. Suppose you want the probability that x is strictly less than 4. There is no or equal to. Well, what you have to do for that the probability x is less than or 4, you need to put it in terms of or equal to. That's the same as the probability that x is less than or equal to 3. So you always have that or equal to in your cumulative density function. So what we would be doing then would be adding these three probabilities together. Okay? And if you go back to the chart and look at your binomial chart, that's 0.001. Let me switch again and show you this. So again, we're working with n, your number of tries 10, x, your number of successes 4 is right here. So we want less than 4. So that's less than or equal to 3. So that's these three added together. Okay. And I forgot to do the 0 down here. In other words, no successes at all, right? So I should say you're adding all of those together, 0, 1, 2, and 3. Okay. Let's get rid of that. Actually, let me just erase this stuff and clean it up. Okay. So now let's say we want to find the probability that X is greater than 4. In other words, we want the probability that it's 5, 6, 7, 8, 9, or 10, right? There's 2 ways you can do that. You can use complements and look at that. All of these probabilities have to add up to 100%, right? Or 1. You can look at that using complements. As the probability X greater than 4 is the same thing as 1 minus the probability that X is less than or equal to 4. Right? We've already looked at that previously. That's 1 minus 0.7, or excuse me, not 0.7, 0.0007. Which turns out to be 0.993. And again, that's using the rounded off to the thousandth place limited in a way values that are on your binomial distribution table. So you can do that using complements, right? So in other words, 1 minus all of these probabilities give you these probabilities, right? And yeah, sorry, I keep drawing this stuff over and over again because of my erasers. All right, so that's one way you can do that. Another way is that you can just directly add up everything that's greater than 4. In other words, find the probability X is 5, 6, 7, 8, 9, and 10 and add those up, right?